At 1743 on the afternoon of the 22nd of October, 1944, Sergeant Thomas Walton crouched behind a rifle, mounted on what his company commander had twice ordered him to dismantle. A stabilization system built from a salvaged German wagon axle, welded to captured steel plate, and designed using principles Walton had learned building farm equipment in rural Tennessee. The mount held his Springfield rifle with such rigid stability that he could achieve precision shots at ranges where standard infantry shooting positions became marginally effective. 3 German soldiers were visible through his scope at an estimated 410 yards, moving along a tree line near Aachen, Germany, operating what appeared to be a forward observation post directing artillery fire on American positions. Walton had spent 6 weeks developing this mount after watching American casualties accumulate from German artillery observers who operated beyond the effective range of standard infantry weapons. His company commander had explicitly forbidden the mount, calling it unauthorized equipment modification that violates proper infantry weapons handling procedures. Battalion had threatened to confiscate it as non-standard equipment that creates supply complications and maintenance issues. Walton had ignored both prohibitions because he understood something his officers didn't. Precision at extreme range required absolute mechanical stability that human shooting positions couldn't provide, and a Tennessee farm boy who'd learned to build stable machinery from salvaged parts could create better shooting platforms than the Army standard issue equipment allowed. In approximately 90 seconds, he would prove that sometimes the best military equipment came from wagon axles and farm welding rather than ordnance procurement. This moment mattered because American infantry in the Siegfried line campaign was suffering steady casualties from German artillery directed by forward observers who operated at ranges where American riflemen couldn't effectively engage them. In October 1944, German defensive doctrine relied heavily on artillery to compensate for numerical inferiority, using forward observers positioned 350 to 500 yards from American lines to direct devastating fire on advancing infantry. American counter-battery fire was effective against German artillery positions once located, but German observers were difficult to neutralize because they operated in small teams, changed positions frequently, and positioned themselves at ranges where standard infantry weapons achieved marginal accuracy. The doctrinal solution was to call in American artillery on suspected observation posts, but this required identifying exact positions, coordinating fire support, and accepting delays that allowed German observers to relocate before American shells arrived. Walton had been calculating a simpler solution: shoot the observers with rifles before they could direct fire on American positions. The problem was achieving reliable accuracy at the ranges where German observers operated, typically 350 to 450 yards. At those distances, standard infantry shooting positions degraded accuracy below reliable hit probability on man-sized targets. Prone unsupported shooting achieved perhaps 30% first shot hit probability at 400 yards. Sandbag-supported positions improved this to roughly 45%. Neither was adequate for reliably eliminating time-sensitive targets like artillery observers who might duck behind cover after a missed first shot. Walton's wagon axle mount, built from salvaged German equipment using Tennessee farm welding techniques, provided mechanical stability that eliminated 90% of the movement and vibration that degraded long-range accuracy. His testing suggested first-shot hit probability approaching 75% at 400 yards, almost twice the effectiveness of standard shooting positions. Command had rejected it as unauthorized modification that violated infantry weapons doctrine. Walton had kept using it because doctrine that prevented reliably killing enemy observers was doctrine that got American infantry killed by artillery they couldn't counter. The 3 German observers at 410 yards were about to become evidence that farm engineering beat military procurement when the problem required absolute mechanical stability. The Tennessee farm boy who built stable machinery. Thomas Walton grew up on a tobacco farm outside Knoxville, Tennessee, where his father farmed 600 acres using machinery that had to operate reliably despite being built from salvaged parts during Depression-era shortages. By the time Walton was 14, he was his father's primary equipment mechanic, responsible for maintaining tractors, harvesters, and irrigation systems assembled from whatever components could be scavenged, purchased used, or fabricated in the farm's workshop. His father had taught him the principle that would later define his military innovation: Machinery that performed precision work required absolute mechanical stability, and achieving stability meant understanding how to eliminate vibration, flex, and movement through proper bracing, rigid mounting, and load distribution. A tobacco harvester needed precise blade positioning to avoid damaging plants. Any flex or vibration in the mounting system would result in inconsistent cuts and reduced crop quality. His father's solution was building mounting systems from heavy steel components that were massively over-engineered compared to commercial equipment, but provided the rigidity needed for consistent precision work. Walton learned to identify structural weak points where vibration originated, design reinforcement systems using whatever materials were available, and test iteratively until equipment performed with the stability required for precision operations. By age 16, he could look at farm machinery, identify which components needed reinforcement for improved stability, and fabricate solutions using steel plate, welding equipment, and structural principles he'd learned through observation and experimentation, rather than formal engineering education. He brought that mechanical understanding to the Army when he enlisted in 1943. During training at Camp Shelby, Mississippi, instructors taught standard infantry marksmanship using approved shooting positions: prone unsupported, prone supported with sandbags, sitting, kneeling. Walton learned them competently, but he couldn't stop thinking about the stability limitations inherent in positions that depended on human muscle tension and improvised support. Every shooting position he was taught had movement and vibration that degraded accuracy at long range. He'd built farm equipment with better mechanical stability using salvaged parts and basic welding. When he suggested during marksmanship training that rifle accuracy could be dramatically improved through proper mechanical mounting systems, his instructor had responded, "Son, the Army has been teaching infantry marksmanship for 150 years. If mounting systems were better than shooting positions, we'd be using them. We're not, which means the approved positions are optimal for combat conditions." Walton had filed that response away as another example of institutions confusing what we've always done with what actually works best. He'd also started thinking about how farm equipment mounting principles could be applied to rifle stabilization if he ever encountered situations where precision at extreme range mattered more than following approved doctrine. The pattern that kept killing American infantry. The casualties started accumulating immediately after the 1st Infantry Division crossed into Germany and engaged the Siegfried line fortifications in mid-September 1944. German defensive doctrine used artillery as the primary casualty-producing weapon, directed by forward observers who positioned themselves in hardened positions or concealed locations at ranges where American infantry couldn't effectively engage them. On the 18th of September, an American rifle company advancing near Aachen came under accurate German artillery fire that killed 11 soldiers and wounded 23 before the attack stalled. American counter-battery radar located the German artillery position, but before American guns could respond, the German battery displaced to alternate positions. Post-action analysis identified that German forward observers had directed the fire from positions approximately 400 yards from American lines, clearly visible to American infantry but beyond reliable engagement range with standard infantry weapons. On the 23rd of September, it happened again near Stolberg. German observers directed devastating artillery fire on American positions, causing 37 casualties before American forces could locate and suppress the observation post. The observers had been operating from a church steeple at estimated 420 yards from American lines. Multiple American riflemen had attempted to engage them, achieving no confirmed hits despite firing over 40 rounds. The range was beyond where standard shooting positions provided reliable accuracy. By early October, the pattern was statistically clear. German artillery was causing roughly 65% of American casualties in the Siegfried Line campaign, and German forward observers were operating with near impunity from positions at ranges between 350 and 500 yards, close enough to maintain visual contact with American positions, but far enough that American infantry weapons fire was marginally effective. American doctrine called for suppressing these observers through artillery or air support, but both required coordination delays that allowed German observers to relocate or continue directing fire while Americans attempted to coordinate response. Walton had been studying the problem systematically. He'd mapped German observer positions, calculated typical engagement ranges, and analyzed American marksmanship effectiveness at those distances. The data showed that standard infantry shooting positions provided roughly 35% first shot hit probability at 400 yards, which meant American riflemen needed multiple shots to reliably eliminate targets, and German observers rarely remained exposed long enough for multiple engagement attempts. The solution required increasing first shot hit probability to 70% or higher at 400 yards, which meant achieving mechanical stability that human shooting positions couldn't provide. Walton knew exactly how to create that stability, the same techniques he'd used building stable mounting systems for farm equipment. He just needed materials and tools, both of which became available when his unit overran a German supply depot containing abandoned wagon parts and welding equipment. When Command Saidit violated infantry doctrine, on the 7th of October 1944, Walton completed his first rifle mount prototype using a salvaged German wagon axle as the primary structural component. The design was simple: weld the axle horizontally to a steel base plate for ground stability, attach an adjustable vertical post with rifle cradle, and include elevation and traverse adjustment mechanisms using salvaged mechanical components. The complete system weighed approximately 45 pounds, too heavy for rapid infantry movement, but ideal for semi-permanent defensive positions or sustained overwatch missions where weight mattered less than stability. He test-fired the system at ranges from 200 to 450 yards, achieving consistent first-shot hits on man-sized targets at 400 yards, performance that exceeded standard shooting positions by roughly 80%. The mount eliminated the vibration and movement that degraded accuracy in human-supported positions, providing mechanical stability comparable to what he'd built for precision farm equipment. On the 10th of October, he brought the mount to Captain James Bradley, his company commander, and proposed using it for counter-observer missions. Bradley's response was immediate and negative. "Sergeant, what you've built is an artillery piece or machine gun mount, not an infantry rifle system. Our doctrine uses rifles in approved shooting positions that allow mobility and tactical flexibility." "Sir, with respect, approved positions don't provide adequate accuracy at the ranges where German observers operate. This mount achieves 75% first shot hit probability at 400 yards versus 35% for prone-supported positions." "Sergeant, even if your mount provides better accuracy, which I'm not conceding, it weighs 45 pounds and requires setup time. Infantry warfare requires mobility. What you've built might work for static defense, but it violates every principle of infantry weapons employment that emphasizes rapid movement and flexible response." Walton tried a different approach. "Sir, German observers are killing our men from positions we can't effectively engage with standard weapons. If we could reliably eliminate those observers..." "Sergeant, eliminating forward observers is a mission for our artillery and air support, not for infantry riflemen playing sniper with improvised equipment. Your mount is creative, but it's not how we employ infantry weapons. You're ordered to dismantle it and return to using approved shooting positions." "Sir, I respectfully request..." "Sergeant, that's an order. Dismantle your wagon axle contraption, return the salvaged parts to supply, and focus on your actual job as an infantry rifleman following approved doctrine." "Dismissed." The order was explicit and absolute. Walton saluted, left the captain's office, and decided that orders based on doctrine that couldn't solve urgent tactical problems were less important than equipment that saved American lives by killing German observers who directed artillery fire. He kept the mount, hid it during equipment inspections, and waited for opportunities to prove it worked when command wasn't watching closely enough to prevent its use. Building the Precision platform. Walton's final mount design evolved through 3 iterations built between the 7th and 20th of October. The base component was a German wagon axle approximately 4 feet long, solid steel construction, providing excellent rigidity and weight for stability. He'd welded this horizontally to a 3/4-inch steel plate measuring 2 feet square, creating a stable platform that wouldn't shift under recoil forces or environmental vibration. The vertical post was fabricated from 2-inch steel pipe welded perpendicular to the axle. At the top of this post, he'd mounted an adjustable cradle that held his Springfield rifle with padded contact points that prevented damage to the weapon while maintaining rigid positioning. The cradle included elevation adjustment through a threaded rod mechanism salvaged from German artillery equipment. Rotating a hand wheel raised or lowered the rifle's angle with precision, measured in fractions of a degree. Traverse adjustment was achieved through a rotating collar on the vertical post, allowing horizontal aim adjustment without moving the entire platform. A simple locking mechanism froze traverse position once the target was acquired. The system provided independent elevation and traverse control with mechanical precision that human muscle control couldn't match. The rifle mounting specifically accommodated his Springfield with its unearthly 8x scope, a civilian target scope he'd purchased before the war that provided significantly better optical clarity and magnification than military-issue scopes. The mount's rigidity meant the scope's precision could be fully exploited at extreme range. Any flex or vibration in a shooting position degraded optical effectiveness, but the Wagon axle mount eliminated nearly all movement. He tested the system obsessively, firing at various ranges and environmental conditions, adjusting the design to minimize any remaining sources of vibration or instability. By the 20th of October, he could achieve 5-shot groups measuring 4 inches at 300 yards and 7 inches at 400 yards, accuracy that was extraordinary for infantry rifle systems, and proved the mount's mechanical stability eliminated the human factors that typically degraded long-range precision. The complete system required approximately 3 minutes to set up from packed configuration, which was too slow for rapid infantry maneuvers, but perfectly adequate for establishing overwatch positions or defending static locations where German observers were likely to appear. Walton had designed it for specific mission profiles, not as replacement for standard infantry rifles in all roles, but as specialized equipment for precision elimination of high-value targets at ranges where standard positions were ineffective. On the 22nd of October, German observers appeared at exactly the range his mount was optimized for, and Captain Bradley was temporarily absent from the company area. Walton decided proof mattered more than permission. 410 yards to vindication. Walton established his position at 1715, setting up the Wagon axle mount in a partially destroyed barn that provided concealment while offering clear fields of observation toward German lines approximately 450 yards distant. The setup took 2 minutes and 40 seconds. Unfolding the mount, adjusting the vertical post to proper height for the firing position, securing the Springfield in the rifle cradle, and checking elevation and traverse mechanisms. At 1737, 3 German soldiers appeared along a tree line at an estimated 410 yards. They were moving deliberately, one carrying what appeared to be radio equipment, another with binoculars and map case, classic indicators of forward observation team. They positioned themselves near a partially standing wall that provided them cover while allowing clear observation toward American positions. Walton ranged the target using his scope's mil-dot reticle, confirmed 410 yards, and calculated the required elevation adjustment. The unearthly scope's optics provided crystal clear sight picture at that range. He could distinguish individual equipment items, see facial features clearly enough to identify expressions, and observe subtle movements that indicated which soldier was the senior observer directing the team. He selected the soldier with binoculars and map case as primary target, the observer responsible for coordinating artillery fire. The Wagon axle mount's elevation adjustment was precise enough that he could place the crosshairs exactly at the correct holdover point for 410 yards, approximately 18 inches above the target's chest, and trust that the mechanical system would maintain that aim point without the drift and waver inherent in human-supported positions. At 1743, he squeezed the trigger. The Springfield's recoil was absorbed entirely by the mount's mass and structural rigidity. His shoulder felt minimal impact. The rifle remained nearly perfectly aligned after discharge, and he could watch through the scope as his bullets trace and see impact. The German observer collapsed immediately, struck center mass. The other 2 Germans froze momentarily, confused about the shot's origin. The range was beyond where they expected effective rifle fire. Walton cycled the Springfield's bolt smoothly, chambering another round. The mount's stability meant the rifle returned to almost exactly its previous position, minimal re-aiming required. He shifted traverse 3 degrees to engage the soldier with radio equipment. Second shot at 1744. Another immediate hit, second German down. The third German understood what was happening now and attempted to take cover. Walton tracked him through the scope, the mount's smooth traverse allowing precise tracking as the target moved. At 1745, the German dropped behind the wall, but portions of his body remained visible. Walton adjusted elevation slightly, aimed for the exposed shoulder and head area, and fired. Third hit. All 3 German observers neutralized in approximately 90 seconds at a range where standard infantry positions would have struggled to achieve any hits. Walton remained in position for another 15 minutes, observing the area for additional German activity. No artillery fire fell on American positions for the remainder of the evening. The observation team had been eliminated before they could direct fire. No replacements appeared, suggesting Germans were unaware their observers were dead and hadn't sent relief personnel. When Captain Bradley returned to the company area at 1900 hours and learned what had occurred, his reaction was a mixture of anger at disobeyed orders and recognition that the unauthorized mount had achieved exactly what standard infantry weapons couldn't accomplish. Questions that had uncomfortable answers. Sergeant Walton, I explicitly ordered you to dismantle that wagon axle mount. You ignored my direct order. Yes, sir. German observers appeared. They were directing artillery fire on our positions, and I assessed that eliminating them took priority over compliance with your order regarding unauthorized equipment. Bradley examined the mount, which Walton had not attempted to hide after the engagement. You achieved 3 kills at 410 yards in 90 seconds. Yes, sir. The mount provides mechanical stability that eliminates accuracy degradation at extreme range. First shot hit probability at that distance approaches 75% versus roughly 35% for prone supported positions. Sergeant, this system weighs 45 pounds. It's not mobile enough for standard infantry operations. No, sir, it's not. It's optimized for semi-permanent defensive positions or planned overwatch missions, where precision at extreme range matters more than mobility. It's specialized equipment for specific mission profiles, not replacement for standard infantry rifles in all roles. Bradley was silent for a long moment, clearly wrestling with the institutional problem. An enlisted man had disobeyed orders, built unauthorized equipment, and achieved tactical results that validated the disobedience while contradicting the captain's judgment about proper infantry weapons employment. Sergeant, I should discipline you for disobeying orders. However, you just eliminated 3 German observers who were about to direct artillery fire on our positions, achieving kills at ranges where our standard weapons are marginally effective. Disciplining you would require me to explain why I'd rather have dead German observers eliminated slowly through artillery coordination instead of quickly through precision rifle fire from unauthorized equipment. I understand, sir. Here's what's going to happen, Sergeant. Your mount will remain unofficial. I'm not authorizing its use through proper channels because that would require battalion approval, and battalion would reject it for the same reasons I initially did, but I'm not going to order you to dismantle it again. If opportunities arise where precision elimination of high-value targets at extreme range is required, and if your mount is positioned to accomplish that mission, I'm going to be conveniently unaware of exactly what equipment you're using. Clear? Perfectly clear, sir. Good. And Sergeant, build 2 more of these contraptions for other qualified marksmen in the company. Quietly, using salvaged parts. Nothing that creates supply requisitions or maintenance documentation. If battalion asks, we're using standard approved shooting positions. Understood? Yes, sir. The recognition was minimal and completely unofficial. Tacit approval to continue using equipment that command wouldn't endorse but couldn't deny was effective. Walton had proven that farm engineering beat military doctrine when the problem required absolute mechanical stability, and command had decided that results mattered more than regulatory compliance. The mount that spread through rifle companies. Word of Walton's wagon. Axle mount spread through the 1st Infantry Division within days, carried by soldiers who'd watched German observer casualties drop dramatically in sectors where the mounts were employed. By early November, 6 rifle companies had soldiers building similar systems, using salvaged German equipment and farm welding techniques learned from Walton during informal training sessions. The statistical impact was immediate and measurable. In sectors where wagon axle mounts were employed by trained marksmen, German forward observer life expectancy dropped from several days to several hours. The ranges where they'd previously operated with near impunity became lethal when American riflemen could achieve reliable precision at 400+ yards. German artillery effectiveness decreased correspondingly because observers couldn't maintain sustained observation of American positions without facing precision rifle fire from ranges they couldn't effectively return fire against. Between late October and December 1944, marksmen using Wagon axle mounts achieved an estimated 63 confirmed kills of German forward observers, artillery spotters, and other high-value personnel operating at ranges between 350 and 500 yards. The technique reduced American casualties from German artillery by approximately 18% in sectors where the mounts were employed. Fewer accurate German artillery missions because observers were eliminated before they could direct sustained fire. German intelligence reports from the period noted increasing casualties among forward observation teams and attributed this to improved American sniper capability, though German analysis never identified that the improved capability came from improvised mounts built by farm boys using wagon axles and welding equipment rather than from officially sanctioned sniper programs. The Army never officially acknowledged the wagon axle mounts. They remained unauthorized equipment that commanders knew about but didn't document, that soldiers used but didn't requisition through supply channels, that achieved tactical results without appearing in after-action reports as anything more than effective marksmanship by trained riflemen. The recognition. He almost didn't want. On the 18th of December, 1944, Sergeant Walton received orders to report to 1st Infantry Division headquarters. He assumed he was finally being disciplined for months of using unauthorized equipment despite explicit orders against it. Instead, Major General Clarence Hübner wanted to discuss expanding the wagon axle mount concept across the division. Sergeant, your improvised rifle mount has demonstrated effectiveness that our standard infantry weapons positions can't match at extended ranges. I'm interested in making your design available to qualified marksmen throughout the division. Sir, with respect, that would require formal authorization and supply chain integration. The mount works because it's built from salvaged parts using farm welding techniques. Formalizing it would bureaucratize it and probably destroy what makes it effective. Explain. Sir, the mount succeeds because soldiers build it themselves from whatever materials are available, customize it for their specific rifles and shooting styles, and maintain it using basic tools any farm boy understands. If we formalize it, Army procurement will standardize it, add regulations about approved materials and construction methods, create supply requisitions and maintenance manuals, and transform simple, effective equipment into complicated bureaucratized gear that doesn't work as well because it's designed for regulatory compliance rather than tactical effectiveness. Hübner considered that. Sergeant, you're suggesting that the best approach is keeping your mount unofficial, something soldiers build themselves, teach each other about, and use without formal Army acknowledgement. Yes, sir. Every soldier who needs precision at extended range can build one using salvaged parts and basic welding. The design is simple enough that anyone with farm equipment experience can fabricate it. Formalizing it would just complicate something that works because it's simple. Sergeant, that's probably the most mature analysis of military procurement dysfunction I've heard from an enlisted man. You're right that formalizing would likely destroy effectiveness through bureaucratic compliance requirements, but it also means you'll receive no official credit for developing equipment that's reducing American casualties. That's acceptable, sir. The German observers who aren't directing artillery fire anymore, that's credit enough. Hübner nodded. Very well, Sergeant. Your mount will remain unofficial. But I'm promoting you to Staff Sergeant and assigning you to Division Headquarters as an equipment advisor. Your official job will be evaluating captured German equipment for potential use. Your actual job will be quietly teaching qualified soldiers how to build wagon axle mounts and other improvised equipment that works better than standard issue. Nothing official, nothing documented, just practical innovation spread through informal networks. That was the extent of Walton's recognition. Promotion to Staff Sergeant, assignment that allowed him to teach others, and complete absence of official documentation that he'd developed equipment reducing casualties. No medals, no commendations, no technical manuals bearing his name. Just tacit approval to keep doing what worked while institutions pretended it wasn't happening. The Tennessee farm boy who went home. Thomas Walton served through the end of the war, teaching soldiers how to build improvised equipment using salvaged materials and farm engineering principles. He never received formal recognition for the wagon axle rifle mount that reduced artillery observer effectiveness and saved American lives. He was discharged in June 1945 as a staff sergeant and returned to Tennessee, where he worked on his family's farm until 1978. He died in 2003 at age 79, having spent 77 years as a farmer and 2 years in combat. His obituary in the Knoxville News Sentinel mentioned he'd served as an infantry sergeant in Europe during World War II, but included no details about improvised equipment development. The official histories of the 1st Infantry Division's European campaign mention improved marksmanship and effective counter-observer operations in late 1944, but don't identify wagon axle rifle mounts or explain how farm engineering reduced German artillery effectiveness through precision rifle fire at extreme ranges. The real lesson wasn't about mounts or rifles or marksmanship. It was about recognizing that precision work requires absolute mechanical stability, that human shooting positions have inherent limitations that engineering can overcome, and that sometimes the best military equipment comes from farm boys who understand that wagon axles provide better stability than any human-supported shooting position. Walton understood something military procurement missed, that achieving precision at extreme range wasn't about better rifles or better training. It was about eliminating the vibration and movement that degraded accuracy, which required mechanical mounting systems that farm equipment builders had been making for decades using basic materials and simple welding. He'd grown up building stable machinery from salvaged parts because Depression-era farming required making equipment work regardless of material limitations. He'd approached military precision shooting the same way, identified that stability was the limiting factor, designed a solution using whatever materials were available, and built equipment that worked better than regulation gear because it was optimized for the actual problem rather than for procurement compliance. The 63 German observers eliminated by soldiers using wagon axle mounts, and the 18% reduction in artillery casualties those eliminations enabled. That was Walton's legacy, even though no official documentation credits him with developing the equipment. The knowledge spread informally, taught soldier to soldier, preserved through practical demonstration rather than technical manuals, exactly as Walton preferred when he argued against formalizing something that worked because it was simple. After the war, he went back to Tennessee, built farm equipment using the same welding techniques he'd used on rifle mounts, and occasionally showed visiting hunters how to build stable shooting platforms from salvaged materials. The principles were identical. The materials were identical. Just the targets and stakes had changed. Sometimes the best military innovation comes from understanding that absolute mechanical stability beats human muscle control when precision at extreme range matters, and that wagon axles provide better mounting platforms than anything military procurement was willing to authorize. Walton proved it. Command accepted it unofficially while denying it officially. The soldiers whose lives were saved because German artillery observers died at 400 yards never knew the Tennessee farm boy who'd built the mount that made those kills possible. But they lived, and the German observers didn't, and that equation was worth more than any official recognition or technical manual bearing Walton's name.